Okay, last lecture of the year. How about that? That's probably sorry to hear that, I'm sure, but last one. That's what I thought. That's what I was looking for. Okay, so solving radical equations. This is, I mean, you'll probably agree this is, I mean, I think the easiest unit second semester. Solving radical equations, no big deal. What's our strategy? We're just isolating the variable, right? Like in a problem like this, we are at least. A couple, and then we'll see some other ones where we can't do that, but this will get us started. If I want to isolate that variable, what would the steps be to get it by itself? You're gonna add or subtract 10, right? First, good. Subtract 10. And then that's going to give us square root of 6w minus 5 equals -7. Now what? Aha, there we go, right? Because now it's grouped inside this square root. A square root, we now know a square root is equivalent to a 1/2 power, right? That's an exponent issue. So when we're going through inverse operations, we're going to go all the way up to the exponent stuff, and we're going to undo that 1/2 power by squaring both sides, right? So in general, what do? What's this telling us about solving radical equations? Well, we always want to isolate the radical. That was our first step, right? Then we're going to raise each side of the equation to the necessary power, which ends up always being the power of the index. Well, this is a square root, so what's the index number for this one? Number, it's on the square root, it's invisible, but it's a what? Yeah, it's a 2, right? So we're going to raise both sides to the second power to undo that radical. Okay, so you know what I'm going to do here? Let's go up here and continue. So then we're going to square both sides. And if I square a square root, what's it do? Cancels it. Good. So we get rid of the square root. That gives us 6w minus 5 equals -7 squared is 49. And then last two steps to isolate the w. Add 5, divide by 6. Okay, what's that going to give us if we add 5 and divide by 6? We get 54 divided by 6. So w equals 9. We good? No, we're not. Because we always, anytime we raise both sides of an equation to a power, so if I'm going to square both sides or something like that, I've always got to check for extraneous solutions because that runs the risk of introducing extraneous solutions when you take both sides to a power. So we would have to take this problem, or this answer, and put it back into our original equation, or maybe not our original equation, but we have to go back to one of the steps prior to squaring both sides. So the easiest one to plug into would be right there, wouldn't it? Right, where we've isolated the radical. So if I plug in 9, what do I get? If I plug that in, I get the square root of 54 minus 5. That's the square root of 49 equals -7. True or false? False. What's the square root of 49? +7. Okay, so because that is not true, that tells us that that is not a valid solution. It's an extraneous solution. So what's our answer to this one? No solution, right? We only got one answer and it was extraneous. So therefore we get no solution. Okay, good. All right. What about one like that? What would I do there? Good, subtract 11. Okay, so this time, and if I want to, how could I write that thing if I wanted to? No? Close. Cube root, because it's a 3 on the bottom, right? So I could rewrite this as a cube root of 7p minus 1 equals -4. You know, before we go any further, let's go back to up here for just a second. Can anybody tell me how maybe they could have predicted what this answer was going to be way before we actually got there? Yeah, because the output of a square root was a negative number. Is that possible? No. What's the smallest output we could ever get from the square root of a number? 0. Yeah, square root of 0 is 0, but square root of any number would always be a positive output, right? We could never get a negative output. So that really should have told us right from the beginning, right there. That guy should have told us that we were going to get no solution, right? Okay, how about down here? We okay this time? We are. Come, you're right. How cube root can be negative, right? Cube root, an odd root can give us a negative answer. Take an easy example. What's cube root of negative 8? Negative 2 is one answer, negative 2, right? Okay, so yeah, that's fine. It's only the odd, or excuse me, the even roots can't give us negative outputs. The odd roots can. Okay, so then what are we going to do here? We've isolated the radical. Now what do I do? Yeah, now I've got to cube both sides, don't I? Okay, because I got to undo the radical. This time to undo a cube root, we cube both sides. So we get, if we do that, so that cancels the cube root. We just get 7p minus 1 equals negative 4 cubed. What's that? Positive or negative 64? Negative 64. Okay, now last two steps. Okay, what do I get then? Okay, I get negative 63, then divide by 7, and I get negative 9. Okay, so we would then need to check that, right, by plugging it back in. Okay, the books always say to check it, and you should, except do you think you're ever going to have a problem when you're taking both sides to an odd power? You know, I guess it's possible. Gosh, I guess it might be possible if you had a higher polynomial. I haven't thought this through, but I don't think you can. I think you're always going to be okay. But just to play it safe, you should probably check it. I want to think about this. If I had a cube root, I think you're always going to get all the solutions. I don't think you're ever going to have extraneous solutions if you're taking both sides to an odd power. I really don't. But I'll let you know for sure. I got to think about it more. Until I verify that, just check everything. So if we plug that back in, like right here, what's going to happen? We end up with the cube root of what's 7 times negative 9 minus 1. Negative 64. Is the cube root of negative 64 negative 4? It is. Good. Okay, it is. No. It's negative 63 minus 1 is negative 64. So it checks. Okay, so that one's okay. Okay, what about this one? This is a little bit different. What's obviously different about this one? Yeah, I got square roots on both sides, and both of them have a variable in it. So what do you think, what's your intuition tell you here I should probably try to do? I don't need a common denominator. It's a similar strategy, but what do you think? Just suggestions. Good. One thing would be divide by 4, right? Both of those coefficients are divisible by 4. So that's a good idea. If I divide everything by 4, those guys cancel. And then I get square root of 3q plus 15 equals, here I would just reduce the 12 over 4 to be a 3 times the square root of q. Okay, now what? You can't just distribute into a square root. I have to be careful about that. There's a way I could do it, but it really doesn't serve any purpose here. What's that mean? You might be right, but I just don't know what that means. Well, the radicand is, but that doesn't really help us. But you guys are thinking about this too hard. What do we have to do if I'm going to solve a square root equation? What have we done in our last two examples? Yeah, we got to undo the radicals, right? So we'll square both sides. Okay. So now we got to change the instructions here a little bit because it says isolate the radical, and we can't always do that. We're going to isolate a radical, right? And then we'll square both sides to undo that radical. Okay, so if I square both sides here, what do I get on the left side? 3q plus 15. Yeah, I just undid the radical, right? So 3q plus 15. Now, what do I get on the right side? Okay, I'm going to get 9q, aren't I? Because how come? Because if I've got a product of 3 times square root of q squared, I have to square both 3 and the q, don't I? Right? So I'm getting a 9q. And now what do we do? Yeah, solve, right? So I'm going to push the q's over to this side, subtract 3q from both sides, and I get 15 equals 6q. I could divide each side by 6, and q would equal 15 over 6, which reduces to what? 5 over 2. Okay. And then I would want to check that, right? So I'll plug that back in up here. That's a little bit inconvenient to check. I mean, we could do it. It's not like it's that big a deal, but I want to use this opportunity to just review with you very quickly how we could use Desmos Scientific to do this for us. Well, you don't even need to graph it because you may not have access to a graphing calculator, but you can do this with a non-graphing calculator. You guys remember how to do that? Because this is a good one to know. If I'm checking, what am I doing when I'm checking? Plugging something in to both sides, right? I just want to see if I get the same thing on both sides. So it's an equation, right? So both sides are equal. So I'm going to I'm going to call function f the left side and g the right side. So I'm going to make this, I could make it x. I'll just make it q because that's what our variable is. But it doesn't really matter. I could just call these x's if I wanted. So I'm going to say f of q equals the square root, forgot my equals the square root of 3q plus 15. And then we'll go down and call g of q the right side, and that's equal to 3 square root of q. Okay, now what? How do I use those? I set up a function for the left side, function for the right side. Now how do I check? No. Okay, and I want that to be q, right? I'm not setting my functions equal to that. I want to plug in that value for q. So how would I do that? How do I plug 5/2 into the function f? Okay, I can say q equals 5 over 2, but that's not going to do anything for me. It just tells me 2.5. Yeah, there we go. Good. Okay, good. So we want to evaluate the function. So I'm going to do f of, and I'm going to replace that q with a 5/2, and I get that weird decimal. And notice there's no fraction button because I can't make it a fraction. It's irrational. That's going to be a square root of something, right? That simplifies to that decimal, or rounds to that decimal. And then how do I check the other side? G of 5/2. Yeah, and I get the same thing, right? So that verifies that solution worked. Yeah, it'd be undefined. Yeah, if it right, if it were undefined. And then in that case, if the Q were a value that made those negative, then it wouldn't be a solution. Okay. If we're looking for real solutions, at least. Okay. So that gives us that one checks out. Okay, give me 1 to 5 so far. How we doing? Okay, okay. Let's look at something slightly different. Okay, this is a different kind. What about that? Yeah, I want to isolate the radical. That's already done. If the radical weren't isolated, I'd have to do some algebra to get the radical on its own. But fortunately for us, that part's already done. Okay, so then what do I do? Well, actually, you already told me, right? I square both sides, right? Next step, square both sides. What's that going to give me on the left side? Okay, so 51 minus 5y equals y minus 11 quantity squared. So what's that? Good. And we're just using our expansion. A plus b squared is a squared plus 2ab plus b squared, right? Okay. Now what? Okay. So we're going to push all this stuff over here. And that's going to give us y squared. I'm going to add 5y to 22y and get 27y. And I'm going to subtract 51. Oh, negative 17. You're right. Yep. And then 121 minus 51 is 70. Oh, what am I? 17, not 27. Okay. And that's all equal to 0. So I just have to solve that quadratic equation. Can you find magic numbers? Okay, y minus 10 and y minus 7. So what zeros does that give us, or what solutions does that give us to that equation? Okay, we done? Okay, what do I have to do? Check them. Okay, so we'll go back up to the top and check those. If I plug those in, let's try y equals 10. So that would give us square root of 51 minus 50. So the square root of 1 equals 10 minus 11, negative 1. True or false? False. So that's telling us that one is not a solution. Let's try the other one. That was y equals 7, right? Okay, if we try that one, we get square root of 51 minus 35. 16 equals 7 minus 11, negative 4. False. So this is an example where both solutions were extraneous. So what's our answer? No solution. Okay, one more. One more. You're getting the idea here. Okay, this is a little trickier. What's makes this one a little trickier? Yeah, square roots on both sides, and I can't get rid of them both at the same time, right? I've got one of them isolated, which is the best I can do. So what's my next step going to be here? I can. That's what I'm going to have to do, right? Because I want to square both sides because I've got my left square root is isolated. So I can undo that one by squaring both sides. Okay, but that's not going to get rid of the one on the right, as we'll see.
Oh, right, because that would make it, since it's a two-term, that would multiply by itself.
Yeah, so we're going to, so when we square both sides, what's that give us? On the left side, what do we get when we square it? X plus 9. Okay, that's easy. What do we get on the right side? Okay, we're going to get x, right? Because that's like saying a plus b, where a is square root of x and b is negative 1. So a squared, square root of x squared, is just x. 2, there you go, plus 1. Yeah, right? Okay, so did that help, that step? Okay, but 1's easier than 2, right? We got rid of 1 square root. Now we just have 1 left over. So where do you think we have to go from here? Isolate that square root and then go through the same process, right? Okay, so we would, to isolate that one, we're going to subtract x from both sides. And we're going to subtract 1. And we get 8 equals negative 2 square root of x. Divide by negative 2. And those guys cancel. And then we get square root of x equals negative 4. Now what? Okay, square both sides.
X equals 16.
Oh, it's not going to work, is it? Okay, so if I square both sides, we get x equals 16. We'd have to check that, right? So if I go plug that back into my original equation, what are we going to get? If I plug that back in, we get the square root of 25 equals square root of 16, which is 4, minus 1. True or false? False. Yeah, that's false. So this is not a solution, right? So we get no solution on that one too. How could we have probably told that one was, yeah, right there. We got that blue equation, square root of x equals negative 4. Gave us no solution because the output of a square root can't be negative. We could have probably seen that one coming. Okay, make sense? Okay, jump in. Last assignment. I'll turn it on.